In late 2022, the brightest gamma-ray burst ever seen shocked astronomers, and even temporarily blinded many high-energy detectors in space. Now, a study of the first few minutes of this burst have found an important feature not seen before. Gamma-ray bursts are the most powerful explosions in the cosmos. One that occurred October 9, 2022, was quickly dubbed the Boat, the brightest of all time. Events like it may occur in Earth's skies only once every 10,000 years. As with most gamma-ray bursts, the Boat arose from the death of a massive star. When its core ran out of fuel, it collapsed, creating a black hole in the star's center. Matter swirled toward the black hole, and some of it was thrown out along two jets moving near the speed of light. The jets drilled their way out of the star and blasted into space. We see a gamma-ray burst when one of these jets happens to point almost directly at Earth. That happens somewhere in the sky almost every day. The closer to head-on we view a jet, the brighter it appears. This, along with an unusually narrow jet, is what made the Boat so exceptional. NASA's Fermi Observatory carries instruments specifically designed for studying these explosions. Its gamma-ray burst monitor was saturated by the Boat's initial flash, but was fine a few minutes later. And it's in that data, around 5 minutes into the event, that scientists found something new. It's an emission line, a narrow band of enhanced brightness in light spread out in a spectrum. It only lasted 40 seconds, but it's the first one ever seen with high confidence during a burst. It gives scientists insight into processes within parts of the jet where gamma rays, the highest energy form of light, come from. Researchers say it's likely produced by electrons and their antimatter twins, positrons, colliding and annihilating within the jet. Each collision produces a pair of gamma rays, but it also works backwards. Two gamma rays can collide to form an electron and a positron. In the jet's environment, both processes occur, so there are plenty of particles to go around. For this to explain what Fermi saw, the gamma rays had to have been shifted to higher energies by their motion. This is similar to a siren rising in pitch as it races toward us. To get that boost, the particles emitting the gamma ray line must have been moving at 99.9% the speed of light. After decades of studying GRBs, scientists know little about the processes within these incredible jets, yet they're a staple of the cosmos. Now, Fermi has given us a brief glimpse inside.